this video, this is 8.6 day 4. We're gonna now focus on just dividing with radicals. And kind of the end of the last video, we talked about we cannot have a square root in the denominator. So anytime you have the square root of a fraction, it's the same as the square root of the numerator divided by the square root of the denominator. So square root of 1 is just 1. And to get rid of a square root, right, I need what's underneath to be squared. So in multiplying by the same thing, I'm really multiplying by 1. And so what I end up having is square root of 3 squared. The squaring and the square root are going to cancel, and I'm left with just square root of 3 over 3. So no square root in the denominator means it's rationalized. We can do the same thing with the cube root. So the cube root of 1 divided by the cube root of 3. Okay, so cube root of 1 is just 1, okay? Now, I do not want this radical left in the denominator. So this time I need something to be to the third power to get rid of the cube root. So right now I have 3 to the first. So what I'm going to do is I'm going to multiply by the cube root of 3 squared, because 3 to the first and 3 squared together will be 3 to the third, and then that will cancel the cube root. Whatever I do on top, I must also do on the bottom. Okay, so let's do that. So straight across, 1 times this is just cube root of 9, right? Over here, I'm going to get cube root of 3 cubed. So this is what I was talking about. The 1 and the 2 are going to give me that cube root that I need, or third power that I need, and the third power and the cube root are going to cancel. So I'm left with the cube root of 9 over 3. Okay, fourth root, same exact idea, okay? So in this one, again, I can think fourth root of 5 over the fourth root of 18. Now, I do kind of like to think in here, is there anything I could take the fourth root of? Well, there's a couple ways I could do this. I'm actually just going to do it like what I did before. So this is an 18 to the first. I need it to be to the fourth so that I can reduce it further. Now I'm going to show you something. I could also break this into smaller factors. This just makes it easier if you don't have a calculator. Okay, so I could do 9 times 2, right? So 2 and 9, I could write like that. So again, this just makes it easier if you don't have a calculator. So if I wanted to rationalize this, so the numerator is the same. What am I doing? Times. So I need these to be to the fourth power. So right now it's the first. So what I'm missing is I need 3 more 2's to get to the fourth power. I already have 2 3's, so I need 2 more to get those to the fourth power. Multiplied by the same exact thing on the top. Okay, so now we have, if I multiply on the top, I'm just going to leave all that stuff to the fourth right now. So I've got 5 times 2 cubed times 3 squared. Okay, and then on the bottom, I'm going to get fourth root of 2 to the fourth times 3 to the fourth, which is just 2 times 3 on the bottom, which is 6. And then because I don't think I have any things to the fourth under here, I don't think I'm going to be able to cancel anything. So let's see, we're going to get 5 times 8 times 9. 5 times 8 is 40, times 9 is 360. So we get the fourth root of 360 over 6. Okay, and yeah, I don't think there's anything, you guys, we can put together there, because if I already have those broken down to their prime factors, there's nothing more I could break it down into, so I'm not able to pull any fourth roots out of 360. Okay, here we're going to assume all the variables are positive so that we can take even roots, but we are going to do the same thing. We're going to rationalize, but first I'm going to simplify what's in the radical. So here 20 divided by 5 is 4, so it's still under the cube root. And x to the 5th, x 7th, if I subtract those, I get x squared. Okay, so again, think of that as two separate roots. Okay, I don't want the root in the bottom. So we're going to, right now I have two x's. I need one more to get it to be x to the 3rd. And we're going to multiply by the same thing on the top. So cube root of x to the 1st. So on the top, I get cube root of 4x. Denominator, I get cube root of x cubed. So the cube root and cube can cancel. And I'm left with the cube root of 4x over x. Okay, cube root of 4/9. Cube root of 4 over cube root of 9. So I need two more 9s here, right? Or I can also think of 9 as 3 squared, right? So then I just need one more 3 to get me to cancel the root. And again, I'm going to multiply the top and the bottom by that. Okay, so I get cube root of 12 on the top. And those 3's, right, cube root of 3 to the 3rd. So those will cancel. So we're left with cube root of 12 over 3. All right. Here I have 5x squared. Again, I'm going to treat this as two separate radicals. Okay, so I need to multiply by two more 5's. So cube root of 5 squared. And I need one more x to get those to be to the 3rd power. Multiply by the same thing in the numerator. Okay, so now I have 2 times 5 squared, so 2 times 25 is 50. So cube root of 50 and then x over 5x when I simplify there. Okay, sorry, maybe I'll show that intermediate step again because I get 5 to the 3rd, x to the 3rd. Those cube roots cancel with the cubed power. So we're going to get cube root of 50x over 5x. Okay, multiplying by the conjugate. So if I have a number that's this, the conjugate is the same exact thing, but we change the sign in the middle. So the conjugate would be a minus the square root of b. So in this case, 5, 2 plus root 5, 2 minus root 5 would be the conjugate. And then I can distribute, but you might actually recognize this is difference of squares. So it's like putting back together the difference of squares. So it's really going to be 2 squared minus root 5 squared is what it's going to end up being. So it's going to be 4 minus 5 or -1. Okay? You can distribute the long way too. You're going to end up at that same spot. Okay, so if we multiply by the conjugate for this one, this is how we rationalize when I have a radical in the denominator that's got addition or subtraction with it, is we multiply by the conjugate to rationalize. So here it's going to be 6 minus square root of 3. So we're going to do 3 times 6 minus root 3 on the top and on the bottom. So again, on the bottom, conjugates are difference of squares in factored form. If we put them back together, we are going to get 6 squared minus square root of 3 squared. And again, that squared is just going to be 3. We can distribute on the top. So I'm going to get 18 minus 3 root 3. So on the bottom, if I simplify, I'm going to get 18 minus 9, which is 9. Oh, maybe I shouldn't have distributed yet, you guys. I'm going to put this back real quick. Well, sorry. I'll leave it. I'll just do it in the next step. Okay, so if I put it back, the reason why you'll see that in a second. Sorry, this should be 18 minus 3, not 9. Square root of 3 squared is 3. So if I had kept that 3 out, you guys will see this here. I'm going to get 15. And then I can actually divide this, right? 3 goes into 15 5 times. So I'm going to get 6 minus root 3 over 5. So maybe wait to distribute on the top just so you can see if it simplifies any further. Okay, this one, we're going to multiply by the conjugate. So 2 minus root 5 and 2 minus root 5. Okay, so on the top, we got this. Numerator, difference of squares. So 2 squared minus square root of 5 squared. Okay, so I'm going to get 2 minus root 5 over 4 minus 5. So I have 2 times 2 minus root 5 divided by negative 1. Okay, so that equals negative 2 times 2 minus root 5. So I could distribute and get negative 4 plus 2 root 5 when I distribute. So if we can get to the point where you don't have a fraction at all, that's definitely more simplified than having a fraction expression. Okay, and I think that is it for this video. Yep, thanks for watching.